Welcome to our practical session where we are gradually navigating from the unknown to the known. In Magicstronics, we give you the first degree of practical understanding. My name is David Okuku, your guardian expert. This is Electronic Circuits Design Plot 2 about voltage regulator IC connection. Let's carry on. In plot 1, we looked at three parameters on a battery: charge, current, and voltage. Voltage being the pressure applied to the flow of electric charges. Today, we are going to see how we can regulate voltage to a particular requirement. Voltage regulator IC connection. I have a few ICs with me, regulator ICs. So the first one here is 7812. Another one that I have is 7808. The next one is 7805. What is to regulate? To regulate is to adjust to a particular specification or requirement. These voltage regulators I'm using here, they are circuits that create and maintains a fixed output voltage irrespective of the changes to the input voltage or load conditions. Voltage regulators are most commonly used in DC-DC power conversions. Some can perform AC-AC or AC-DC power conversions as well. In this video, I will focus on a few DC-DC voltage regulators, the ones that I'm having here. The rest, we shall look at them later in circuits connection. We have 7812 that will give us 12 volts as our voltage output. We have 7808 that will give us 8 volts as our voltage output. And here, the last one is 7805. So, the reason as to why we are using these voltage regulators is because we want to keep the voltages from our power supply within a range that is compatible with other electronic components. The design of regulation that I will use here is step-down regulation. So I'll dismiss 7812, 7808. I'll remain with 7805. For this particular regulator IC, the first pin is on the input, the middle pin is on the ground, and the third pin is on the output. Just to tell you something, an IC is usually read from left to right. So pin number 1 is this one. We have pin number 2 as the middle one, and pin number 3 for the output. In a voltage regulator, capacitors are placed at the input and output terminals between those pins and ground. Their primary functions are to filter out AC noise, suppress rapid voltage changes, and improve feedback loop characteristics. In our circuit, we have on the input side, we have 0.22 microfarads. And because the maximum voltage of this particular IC, the maximum input voltage is 35 volts. So I'm using a 50 volts 0.22 microfarads capacitor on the input side. And on the output side, I'll have a 50 volts 0.11 microfarads capacitor. So for me to get an output of 5 volts, and because this is a step down regulator, I'll have, for example, say a battery, a rechargeable battery, or a battery or a source of supply. For example, this is a 9 volts battery, and I need to obtain 5 volts from it. So we are going to create the circuit. We have our 9 volts that will create a voltage of the input side. So in my power rail, I'll mount my positive here, my negative pin here. So, and in this circuit we are being shown that from the positive and negative input we have a capacitor, a 0.22 microfarads capacitor. So I'll place this capacitor of mine between the 2 terminals. Remember, this is the negative side of the capacitor. This is an electrolytic capacitor that have polarities. So that is my placement. Now in the circuit area of this breadboard, I'm going to mount my 7805 IC. There I've placed. So from the input positive, we channel it to the input of the regulator, that is pin number 1. And from the input negative, we channel it to the middle pin of the regulator, pin number 2. And from the same ground, we have an output ground. There I've placed it. And we have pin number 3 as our output, positive. And we also have a 0.01 microfarads, 50 volts, between the output pin and the ground. So we are going to place it respectively. There we have. Now using my meter, the meter I have here, I'll adjust it to a range of voltage that is slightly above my expectation. So I'll measure the potential difference between the output pin and the ground, and there I've achieved 5.01 volts. So this is basically what a regulator does. It adjusts the voltage to a specific requirement of the circuits beyond it, so that we can safeguard our circuits from overvoltages. We can connect any circuit that uses 5 volts after that on the output side. So for example, here I want to connect a simple LED to demonstrate. So this is a 220 ohms resistor, and I have my red light emitting diode here. This is my ground pin. The one that I'm using, the regulator that I'm using, 7805, it usually has a maximum output current of 1 amperes. If my load draws more than 2 amperes, or let's say 2 amperes, and you know this 7805 has a limit of a maximum output current of 1 amperes, so you can connect 3 of them. So 3 will provide a limit of up to 3 amperes. So that means your circuit that draws more than 2 amperes or 2 amperes to be precise will be safe with these ICs. Otherwise, if you connect a high current drawing load, it will make the ICs to burn out. Did you like our show? Therefore, sons and daughters, the only thing that will keep us going is your sufficient blessings to our channel by simply subscribing to get track of our updates. Plenty content is awaiting. I hope you like it. Thank you.